So here's the schematic I drew on the whiteboard. At the bottom here, you can see I got the four ports, and 2 of them are PWM, so I can analog right to the motor to change the speed. And over here, I got the motor, and here I have the H bridge, as well as the switch up here connected to a 10 kilo ohm resistor. And then when I press this button up here, then the H bridge will switch what direction the positive and negative wires are at, so that it will change the direction of the motor, either left or right. So here's my circuit plotted out on the breadboard, and the motor's moving around on the table, and it'll move in the direction that the motor's spinning just because of the vibration. Unfortunately, the frame rate of the camera wasn't good enough to actually capture the speed of the tape that I put around it. So you're just gonna have to trust me that the analog right was actually working. But you'll be able to see it in the code. So yeah. Now it's time to go look at stepper motors. Here's the schematic that I made for the stepper motor. Here I got the H bridge. Here's the stepper motor. Here's an extra, just a barrel jack for extra voltage. I didn't end up needing it, but it's there anyway. And then here is the Arduino. So here's the stepper motor circuit plotted out on the breadboard, and as you can see there, the barrel jack is being used here. I unplugged it, plugged it back in, and there really wasn't any difference in the performance of the stepper motor. So yeah, that didn't end up really doing anything. But here you see the stepper motor ticking. It's doing the one step at a time. This is just a simple program that you can find in the Arduino examples. So yeah, now I'm gonna go on to making an actual project out of this motor. So for my project for this lab, I decided to just make a simple clock that just ticks in seconds, made out of cardboard. So here's a clock I made in Illustrator, just a simple outline, and then here's a hand right here. So I'm gonna cut that out. Then it's gonna get this cut right here. After cutting it, this is what it looks like. Got the clock and a little ticker hand thing. It's gonna go right there. Like that. So here's the final product. It's my cardboard clock, and it's pretty accurate. It's currently counting in seconds, and as we can see over here, the second it hits 12, I'm gonna hit start, and it'll go to 5, and you'll be able to see how it gets to there at 5, there at 10, there at 15. So yeah, it's pretty accurate. And that's it.